Hello guys, in our previous video we have been talking about the inversion of control design principle. We saw that this design principle brings many advantages such as maintainability, extensibility, testability, and many others. We saw that this design principle is implemented by many design patterns such as the service locator pattern, the factory pattern, the dependency injection pattern, and many others design patterns. And in this video, we are going to see how the dependency injection pattern implements this design principle. So guys, let's crush this. Dependency injection allows the creation of dependent objects outside of the class. These objects are then injected into the consumer through different ways. The dependency injection involves three types of classes. As we can see on this diagram, we have the consumer class, which is the dependent class which needs a dependency in order to fulfill its function. Then we have the service class. The service class here is the dependency needed by the consumer. And then at the bottom we have the injector. The injector here has the role of instantiating an instance of service, then inject it into the consumer class. So as we see in this diagram, the injector is in charge of the instantiation of the service and inject it into the consumer. This can be done following three different ways. Here we have the constructor injection way. In the constructor injection way, the injector supplies the service to the consumer via the constructor of the consumer. In the property or setter injection way, the injector supplies the dependency via a field or a property of the consumer class. And in the last approach, which is the method injection, the consumer and the injector implements an interface, and via this implementation and interface, they will inject the dependency while implementing a method of this interface. So these are the three different approaches of implementing the dependency injection. And here we are going to focus on the implementation following the constructor injection way. In our implementation, we are going to use this case. Our service will be the real service. Our consumer will be the garage. Then we will have a real service injector which will be in charge of the creation of the real service and inject it into the garage. So guys, let's go and see how this is implemented in our IDEs. Here is our implementation examples. Our service here is named real service. In fact, it's an interface which declares the contract to be implemented by each service. So we have two services which implement the real service. The first service is the alloy real service which implement the real service. And given that the alloy real service implement the real service, it has to implement the method of the real service, and it has only one method, which is real type. It takes into parameter the shape and the manufacturer of the wheel. These properties are of type, these arguments are of type string, and it will return a string alloy wheel of shape, given the shape manufactured by and give the manufacturer. That's all about the alloy wheel service implement. Then another service is steel wheel service implement, which implements the wheel service also, and the implementation of the method wheel type is it returns, in fact, steel wheel of shape. It gives the shape manufactured by, it gives the name of the manufacturer, and that's all. Then we will go to our consumer. The consumer here is also defined by an interface, and each consumer will have to implement this interface. It has one method declared, mount wheels. Let's see how my garage, which is our service, implements this. My garage implements the garage interface. It has a property named wheel service, and this property is an instance of the service. So my garage needs an instance of the service, and this instance of the service will be provided to my garage via the constructor. As we can see here, the constructor takes into parameter an instance of wheel service, and it will instantiate the field service with wheel service received via the constructor. So we can see that here an instance of wheel service is injected to our consumer, my garage, via the constructor. And as simple as it is, our mount will in fact just print the final message. So the service is used, and after we just print the message. That's all concerning our consumer. Then we go to the injector. The injector also has an interface, and the interface declares the contract to be implemented by each injector. Given that we have two services here, each service has to implement its own injector. So the alloy wheel service has its injector, and its injector returns a new instance of my garage injected with the wheel service, as you can see here. So what we see here is that the injector creates an instance of our consumer class and inject an instance of the service class in it, and it will return an instance of the consumer. It will be the same with steel wheel. Here, the wheel service will create a new steel service implement. Then we will return an instance of the consumer, my garage, injected with the wheel service that we created previously. All of this is used in my garage test, in fact, to test. So here we have C-shape, which is concave, manufacturer 1AV, which is 1AV. These are just the arguments that are needed to construct our example. Then we will create an instance of the injector, initialize it with null. Create an instance of our garage, we initialize it also to null. Then this is where we use our injector. Injector, we will call an instance of the alloy injector, for instance. Then when we have an instance of the injector, what we do is our garage, we call the injector will return an instance of the consumer. That's where we initialize our consumer with an object coming from the injector, which already has the service injected in it, and we can only call the service garage.mountsWheel, giving it the shape and the manufacturer. This will also done with the next service, steel wheel service. We get an injector of the steel wheel service. Then, having that wheel service injector, we will call the get garage to get an instance of our consumer. Then we can call the service that we need, and that's it. Let us test and see if the output is expected as it should be. Okay, given that our first injector is of type alloy wheel service, and in alloy wheel service, we saw that the method mount wheel was going to return alloy wheel of shape, color, it gives the shape of the wheel. Then manufactured by, colon, it gives the manufacturer name. So that's what we have. When we call the alloy wheel service injector, we have this output. When we call the steel wheel service, we have this output. And that's it concerning our implementation. We can see that our class is only responsible of using the service. The instantiation and the binding is given to the injector class. This brings many advantages. For instance, if we have to extend our service to insert another wheel service, all of what we will have to do is to implement new service and new injector. So this solves the problem of hard-coded dependency, and it helps us to have extendable classes. Considering all of this, we can say that dependency injection brings many advantages. And the first advantage is the separation of concerns. The second is it helps to have configurable component. The last but not the least, it helps to integrate easily the test using mock objects. So that's all we had to say about the dependency injection. You can have a look on our previous video where we were talking about the inversion of control principle. In the upcoming video, we are going to talk about the implementation of the dependency injection in the Spring Framework. So guys, see you in the next video. Bye-bye.